Section 2 covers questions 5 through 7. 5 through 7. It says, if a house is selected at random from the street, what's the probability that it has an attic and a basement? Attic and a basement. So let's see how many kids fall in that, or how many houses fall in that and category. Well, these are all my attics, these are all my basements, and these are the houses in between that have both attics and basements. So that would make this answer 23 out of 100, which is 0.23. Now it does say over here, set notation. A intersect B means that the outcome belongs to both A and B. A union B means that the outcome belongs to A or B. And little c in the subscript means, superscript, means that the outcome does not belong to the set. Write the answers to questions to items 3 through 5 using probability notation. Use set notation as necessary. So, question number 3, we asked for the probability of an attic, right? So probability of attic equals 0.52. Question number 4, probability of a basement equals 0.57. And lastly, the probability of A and, so that's this intersect, A intersect B, and we know that that equaled 0.23. What is the probability that it has an attic or a basement? Attic or basement? Well, we know that the total is out of 100, right? Well, attic only is 29. Attic and basement is 23. And basement only is 34. So I'm going to add those up. So we got 6. That's going to be 6, 8. 8 over 100. 86 over 100, which is 0.86. What is the value of A, probability of A plus the probability of B? Well, we already know that the probability of A was 0.52, and the probability of B was 0.57. So 0.52 plus 0.57 equals 1.09. That's higher than 100%. Construct valuable arguments. Explain why the probability of A plus the probability of B is not equal to the probability of A union B. Well, if we take a look, when we found the probability of A plus the probability of B, that equals all of A and all of B. But you will notice that the probability of A and B, or A intersect B, contains to both problems, is in both circles. So we don't want to add it twice, so we need to take it away once. So if I do the probability of A union B, it's going to equal the probability of A plus the probability of B minus the probability of A and B. Because otherwise, this section right here is getting added with this circle, and it's turning around and getting added with this circle. So we only need to add it once. So I can subtract it once to get out of there. So let's generalize. Suppose that various combinations of events A and B have the probability of P, Q, R, and S as shown in the Venn diagram. To calculate the probability of A union B, we're going to take P plus Q plus R. To calculate the probability of A, you're going to find the P plus Q, and to calculate the probability of B, you're going to add Q and R. If we calculate the probability of A plus the probability of B, we get P plus Q plus Q plus R, which includes two Q's. So in probability of A union B, we want only one Q. Now, when we want only one Q, we need to remember the following. When we calculate the probability of A union B using probability of A and B, we have to subtract Q, which is the probability of A intersect B. This includes the following formula. Probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B. This formula is called generalized addition rule and is often simply referred to as the addition rule. On to your debriefing question.